Hey guys, we're going to be learning about adding and subtracting radicals today. That's section 3 of chapter 9. It's a pretty easy section, really. Um, what you have to do is just add and subtract, so that's not a big deal. For them to be like radicals, they have to have the same index and the same radicand. So the number inside of the radical has to be the same, and the index has to be the same. So you kind of think of them like x's. So the first problem is 4 square roots of 5 plus 3 square roots of 5. So, like I was saying earlier, they have to have the same roots attached to them. So the square root of 5 and the square root of 5, that's the exact same thing. Um, so you think of it as like, what's 4x plus 3x? Well, 4x plus 3x is 7x. So 4 square roots of 5 plus 3 square roots of 5 would be 4 plus 3 is 7 square roots of 5. So you just add the parts out front, and then the radical just stays the same. On number 2, I just want to make sure, remember, just like if this were x minus 6x, you would think of it as 1x minus 6x. So 1 square root of 10 minus 6 square root of 10 is negative 5 square root of 10, because 1 minus 6 is negative 5. On number 3, notice we have a cube root of 7, a cube root of 7, and a cube root of 5. This one is not alike. These two are. So again, put the understood ones in front. 1x plus 1x is 2x, so that would be 2 cube roots of 7. And then 4 cube roots of 5 would just tag along. We cannot combine them. This is like an x, this one's like a y. They are different, so they have to stay separate. On number 4, we have 2 square roots of 6 plus 5 cube roots of 6. So once again, the square root of 6 is different than the cube root of 6. So this is like a 2x plus 5y. We could not put those together, so this one can't go together either. So you just say cannot be simplified further, or already simplified, or something to that effect. If you want to pause the video here and try 5 through 8, that would be great. On 5, you should have gotten 8 square roots of 2, because 3 plus 5 is 8. On 4, this is like, on 6, this is like 4. These cannot be simplified further because one is a square root of 13, the other is a cube root of 13. On 7, put the understood 1 out front. 1 square root of 6 minus 8 square root of 6 is negative 7 square root of 6. And then on 8, these first two are alike. The second one is not, so it's going to be rewritten. 6 minus 2 is 4. So you get 4 fourth roots of 5 plus the fourth root of 7. So let me know how you did, and you can comment below. Objective 2, we're still going to be adding and subtracting radicals here, except for what you'll notice is at first glance these look like they are not able to be combined, but we'll simplify these radicals like we did in the last section or two, and we'll see that they actually end up being able to be added together. So you just look at it and remember your perfect squares. So what perfect square divides 50? That's 25. So 25 times 2 is 50. So that's 5 square root of 2 when simplified. The square root of 8, 4 times 2 is 8. And the square root of 4 is 2. So now that we've simplified those radicals, you see that, hey, they are alike. 5 square roots of 2 plus 2 square roots of 2 is 7 square roots of 2. On number 2 here, we've got a coefficient out front. That doesn't really, it's okay. It'll still be just fine. So what perfect square divides 12? That would be 4. 4 times 3 is 12. Square root of 4 is 2. So remember, if things are touching, they mean multiplication. So we would have 7 times 2 times the square root of 3. And that would be 14 square roots of 3 when we put that all together. Okay, and then the square root of 75, what perfect square divides it? That would be 25 times 3. So that's 5 square roots of 3. Put a minus sign there. 14 square roots of 3 minus 5 square roots of 3 is 9 square roots of 3. On number 3 here, we just got 4 of them. It doesn't make it any harder. Square root of 25, that one is a perfect square. The square root of 27 is 9 times 3. So again, if you know your perfect squares, these are very, very quick, very easy. So work on memorizing those perfect squares. The next one, we would have 2 times 9 times 2, because 9 times 2 is 18, and 9 is a perfect square. The square root of 9 is 3, so we have 2 times 3 times the square root of 2, so that's 6 square roots of 2. And then on the back there, we've got the square root of 16, which is just 4. So all I need to do here is kind of just line everything up with my symbols. So I have 5 minus 3 square roots of 3 minus 6 square roots of 2 minus 4. So which of those can go together? Well, the square root of 3 and the square root of 2 are different, so those can't go together. The only things that I can put together is the 5 minus 4. 5 minus 4 is 1, and then everything else will be rewritten. If you want to again pause the video here, try 4, 5, and 6. See how you do. All right, let's see how you did. This is 9 times 5, so that's 3 square roots of 5. This is 4 times 5, so that's 2 square roots of 5. Put those together, 5 square roots of 5 for a final answer there. On number 5, that would be 49 times 2, so that's 7 square roots of 2. And this one is 4 times 2, so that's 5 times 2 times the square root of 2. That would be 10 square roots of 2. 7 square roots of 2 minus 10 square roots of 2, negative 3 square roots of 2. And then 6 here, square root of 36 is 6. 4 times 6 is 24. This one here, 4 times 10 is 24, or is 40. And that one, 25 times 6. Okay. Simplify these things. The square root of 4 is 2, so 3 times 2 is 6 square root of 6. And the square root of 4 is 2 square roots of 10, and the square root of 25 is 5 square roots of 6. So look at those. Which of those can go together? The only ones that are alike are the square roots of 6. So 6 square roots of 6 minus 5 square roots of 6 is 1 square root of 6. I don't need the 1. I just write the square root of 6, and then the 2 square roots of 10 will come afterwards. All right. So there's that front side. Let me know if you have any questions. Let me know if you did well there. And then on the back, we're just going to add a couple variables in there. So we're just going to simplify it like we have been. Remember, index divides the exponents of the variables. So if you put the index of 2 here, how many times does 2 go into 2? It goes into it once with a remainder of 0. Remember, this number is the exponent outside of the radical. This number is the exponent inside of the radical. So that means it would be 2x to the first with nothing left inside, so it's just 2x. Here, I'm going to break it down into the pieces. I've got the square root of 25, and I've got the square root of x to the fifth. The square root of 25 is clearly 5, and then square root has an understood index of 2. How many times does 2 go into 5? It goes into it twice with a remainder of 1. So what does that mean? I have the 5 out front. These are the exponents. So this would be x to the second with a remainder of x to the first. And then this one, we just did it. It's 2 remainder 1. So it's going to be x squared with a remainder of x to the first. And then I just need to put my symbols, plus, minus. Okay, so which of these are alike? Now notice both of these have a square root of x attached to them. So those two can go together. So I have, don't forget the symbol up front, negative 5x squared plus the understood 1x squared. Negative 5x squared plus 1x squared is negative 4x squared. And then just tag along that radical. Then don't forget that 2x that was up front. And that's as simplified as that gets. It's not a great answer, but that's what it is, you know. Let's look at 2 together as well. Again, index of 2. So how many times does 2 go into 3? Once with a remainder of 1. So that'd be x to the first with a remainder of x to the first. This one cannot be simplified any further, so we'll just rewrite it. And this one, clearly the square root of x squared is x. Which of those are like radicals? Once again, these two are. So remember, this one has an unregistered 1 in front of it. What's 1x minus 8x? 1x minus 8x is negative 7x. Tag along that square root of x, and also tag along that plus 3x at the end. Okay. Down here at the bottom, we have a couple of cube root problems. So remember, instead of looking for perfect squares, we're looking for perfect cubes. So we'll break this down into the pieces. We have 5, we have the cube root of 16, and we have the cube root of x cubed. Okay. So what perfect cube divides 16? That would be 8. 8 times 2 is 16. And then this one, how many times does 3 go into 3? Once, with a remainder of 0, right? So that would be representing x. Okay, now I just need to kind of simplify a little bit more. The cube root of 8 is 2. And then everything else I'll just kind of rewrite. Okay, now I want to put all of the things outside of the radical together. So that'd be 5 times 2 times x. So 10 times x is 10x. And then I've got the cube root of 2 also. Okay, that part is simplified. Now let's look at the cube root of 54. What perfect cube divides 54? 27, right? 27 times 2 is 54. And then once again, I have that cube root of x cubed, which clearly is x. Okay, cube root of 27 is 3. The cube root of 2 does not simplify. And the cube root of x cubed is x. So again, put those pieces outside together. So that would be 3x and then the cube root of 2. And we look, do those have the same radicals attached to them? Yes, so I can put these together. What's 10x minus 3x? 10x minus 3x is 7x. And then don't forget to tag along the cube root of 2. So your final answer is 7x cube roots of 2. All right, one more. If you want to pause the video here, you can. Try this one out for yourself. Okay, let's see how you did. So I have the 4 out front. I'm looking for, again, perfect cubes. So what perfect cube divides 81? Again, it's 27. 27 times 3 is 81. And then I've got the cube root of x to the 6th. So all of those pieces just from that first one. All right, let's simplify those. What's the cube root of 27? It's 3. Cube root of 3 does not simplify. And then this one, how many times does 3 go into 6? Twice with a remainder of 0. So that's representing x to the 2nd. Okay, so put all of those pieces outside of the radical together. The 4, the 3, and the x squared. So 4 times 3 is 12, so I would have 12x squared cube roots of 3. Okay, that one's done. Now let's look at this second piece. What perfect square divides 24? That would be 8 times 3 is 24. And then the cube root of x to the 6th. So again, cube root of 8 is 2. Cube root of 3 does not simplify. And then how many times does 3 go into 6? Twice with a remainder of 0. So once again, x squared. Put those pieces outside together. So that would be 2x squared. And then the cube root of 3 tags along. There was a minus sign between these two. So are these alike? Yes. So it's 12x squared minus 2x squared. 12x squared minus 2x squared is 10x squared. And then the cube root of 3. Awesome. So there you go. There's that problem. Let me know if you need any help with anything. Good luck on my math lab. We'll talk to you soon. Have a great day, guys.